Hey guys, Chapter 6, Section 2 video here for you. Today we're going to talk about the essential question of what other types of roots can I find? So we've been just introducing and talking about square roots, but that is not the only type of root you can find. So we're going to get into some other types today. Before we begin, we're going to do a little review in our notes. Most of what we're talking about right now can easily tie to some geometry concepts. So we're going to talk about one-dimensional versus two-dimensional objects. In fact, I plan to make a big T-chart of one-dimensional versus two-dimensional. Now, one-dimensional are things like rays, lines, line segments. They're things that can be measured with a ruler and have basically one measurement. How long are they? That's basically it, is how long are they? You can measure in inches, centimeters, feet, whatever you want to measure in, but you only get a single measurement, their length. Two-dimensional objects are the shapes you learn like in elementary school, like rectangles and triangles, those kind of things. Now, one dimension only has length, but what do the two-dimensionals have? Well, they have a length and a width. You can take your ruler and measure two ways. So I'm going to write two dimensions have length and width. That's why it's called one dimension and two dimension. One dimension only has one length. Two dimensions has two lengths, a length and a width. So that's kind of hence the name. So let's talk three-dimensional. Three-dimensional has a length, a width, and a height. It's got three measurements. So here's an easy example. This rectangular box is a three-dimensional object. Now, you can put your pencil down for this part of the video, but I'm kind of curious, what's your knowledge of three-dimensional? So I'm going to give you a couple of things here and we'll just see if you know them. Any of the flat surfaces on a three-dimensional figure are called a what? What do they call the flat surfaces? This would be a flat surface, or here's one, or here's one, or here's one, or there's the front and the back. Those are called faces. So when we're talking three-dimensional objects and I say look at the face, I'm talking about one of the flat sides. How about where do the two faces meet? So like here would be a great example of where two faces meet. See the two faces meeting right there? We call that an edge. It's the edge of the three-dimensional object. What about a point where all three edges meet? Like here, what do we call that? A lot of people want to call it a corner, but it's actually called the vertex of the object. So a vertex. All right, pick up that pencil. We're going to do an example. And our first example, we have this three-dimensional box. It's in a perfect cube shape. And what we're going to do is divide it into little cubes. Think of Rubik's Cube as a good example. And the question is how many little unit boxes are inside this object? How many unit cubes are in the larger cube? Hit the pause button and make a quick guess on that. How do you see this? How many cubes are in there? Well, it's 3 units tall, it's 3 units wide, it's 3 units long. So all together, what we have here is a volume of 3 times 3 times 3, which is 27. There are 27 little boxes inside this object. And you may have saw that a lot of different ways to figure that out, and that's totally cool. But what we write for the volume is we say it's 27 units cubed, because they're little cubes, units to the third power. Now, why are we reviewing all this geometry? Well, because it's going to relate to what we're doing with roots here in a minute. For example 2, I'm going to tell you that I have the volume of a cube, and I already know the answer is it's 125 inches cubed. What are the dimensions of this box? Okay, well let's think about this problem here for a moment. We have a box that has a volume of 125, but we don't know the dimensions. It's x by x by x. It's unknown. But what we do know is if it's x times x times x, then x times x times x is the volume, and the volume is 125. That means x to the third power is equal to 125. How do we solve for x? Well, we could do something. We could take what we call the cubed root of the x. The cubed root of x to the third is x. What's the cubed root of 125? What number, if we times it 3 times, is 125? 5 is. X is equal to 5. Look, we'll check it. Let's do a little check here and make sure that's actually the right answer. Here's our check. x times x times x was supposed to be 125. That means 5 times 5 times 5 has to be 125. You could grab a calculator if you need it or just do it in your head. 5 times 5 times 5 is 125. It does work. There's our solution. All right, so we're going to make a little table now in our notes of cube versus cubic root. To cube a number means to multiply it 3 times. So 3 to the third would be 3 times 3 times 3, which is 27. Or 4 to the third would be 4 times 4 times 4. Do you know what 4 times 4 times 4 is? 64. We could keep doing this. We could do 5 to the third, 6 to the third, but you get the idea. But the opposite of all this is the cubic root. So it looks like a square root, but we put that little 3 inside the corner there. So this cubed root of 27 would be 3, because 3 times 3 times 3 is 27. The cubed root of 64 would be 4, because 4 times 4 times 4 is 64. Another way we could do this is we could use fractional powers. We could say 27 to the 1/3 power, which is 3, or 64 to the 1/3 power, which is 4. Both ways mean the same thing. All right, so now I'm going to have you try some problems here. I'm going to give you an ABC. Your job is to solve each of these. Hit the pause button on your device and see if you can do it. All right, you ready to check your answer? 343, but we want the cubic root. Well, the answer is it takes 7 times 7 times 7 to get 343. So the answer is 7. How about for 1,000 to the 3rd power? Did you know to find 1,000, it's 10 times 10 times 10? So the answer is 10. How about -8? Now, if you watched my prior video, you saw that when you square root a negative number, it's impossible to do, and we call it this imaginary number. But when you cube root it, it is possible. Watch. -2 times -2 times -2. Now, 2 times 2 is 4, times 2 is 8. And a negative times a negative is a positive, but times another negative goes back to a negative. So we actually have a cubed root of a negative number is -2. There's our solution. How'd you do on these? Did you get the same thing as me? Did you get stuck on any of them? All right, guys, so cubes and cubic roots are opposites of each other, just like squares and square roots are. I hope this video helps, and we will practice in class.